Hi, my name is Jack Romanos, and I'm a technical trainer here at Amazon Web Services. My job is to teach people about AWS services to help them to learn, upskill, and certify in cloud technologies. We are very glad to have you join us today at Awesome Day Online Conference. In Module 4, we're going to take a look at innovation with AWS. We have 5 key components to discuss in this section. We're going to talk about IoT or Internet of Things on AWS, machine learning, blockchain, AWS Ground Station, and AWS Wavelength. With technology as the enabler of innovation, AWS is your trusted advisor, uniquely positioned to help your organization shift to an operating model optimized for innovation. We'll start off with IoT, or Internet of Things. What is Internet of Things, or IoT? IoT is where a system of integrated devices, such as appliances, watches, features in a car, or even toasters, can be connected to various applications. These connections enable the data to be transferred to and from devices in bidirectional communication flow over a network. That telemetry data can actually be collected and captured from various embedded sensors, microcontrollers, actuators, processors, and communication hardware that is in the surrounding environment. Automating data collection can reduce the need for human-to-human or human-to-computer interactions. With the number of devices that we have today, and billions of IoT devices coming online, there are some inherent challenges with managing large fleets of these things. First of all, are the overall updates. We've got devices with firmware, we have microcontrollers and sensors that have very lightweight firmware and need hardware that we need to be able to keep updated or in sync. Sometimes there are issues with network connectivity. These sensors or devices can be on ships or on various different moving objects where they don't consistently have stable internet connections. The second issue that could arise is that because these devices are remote, they might not be physically accessible. They may be built into equipment, so we may not be able to readily connect wires to them and update them. And lastly, we might have potentially large fleets of devices in production that we have to manage. How do we manage all the communication to and from the sensors and maybe between the various sensors? Also, from an analytics standpoint, we might have very low compute power, maybe low spec on-device resources. In that case, we may not be able to do calculations or analytics on board directly on the device. But these devices may also emit very large volumes of streaming data that we need to analyze at a later point. The question is, how do we actually get that data out? How can we manage all these remote devices from the remote standpoint? AWS has IoT services for many of these areas that we just talked about. If you need to take data off those devices, stream them into a central location, and analyze them, we have solutions like AWS IoT Analytics, IoT Events, and IoT Things Graph. From the standpoint of managing device software, we have FreeRTOS, IoT Device SDK, IoT Greengrass, and IoT Device Tester. And then finally, to actually connect and control these various different devices and provide services that allow us to be able to manage the messaging and communication between these different devices, we have IoT Core, IoT Device Management, and IoT Device Defender. Customers in various industries are using AWS IoT in applications for improving industrial processes. An example would be remote patient health monitoring solutions that enable healthcare providers to remotely monitor the status of a connected sensor. Measuring and collecting field, crop, and ambient data are key capabilities enabled by AWS IoT solutions. IoT is used for connected vehicle and autonomous driving capabilities too. AWS IoT makes it easy for you to build, scalable IoT applications that collect, process, analyze, and act on data generated by connected home devices without having to manage any infrastructure. AWS IoT Core can use AWS services as building blocks to set up a secure and powerful IoT deployment. With AWS IoT, you can build solutions that help you respond to events in near real time and reduce your concerns about scale, enabling you to focus more on your core business. As you can see here, AWS IoT is connected to multiple different AWS services, some of which we've talked about already today. AWS Lambda to run your business logic, DynamoDB for your database layer. You can build IoT applications that gather, process, analyze, and act on data generated by connected devices. AWS IoT Greengrass is an Internet of Things or IoT open source edge runtime and cloud service that helps you to build, deploy, and manage IoT applications on your devices. It enables your devices to act locally on the data that they generate, run predictions based on machine learning models, filter, and aggregate device data, thus saving you time, especially in cases where milliseconds matter. In farm fields across the globe, Bayer Crop Science is planting and harvesting seeds to help farmers improve global food systems. Bayer Crop Science uses AWS IoT for collection, processing, and analysis of seed growing data. This solution captures terabytes of data and enables analysts to pull up dashboards from the collection platform. Using AWS IoT, visibility into field conditions is more readily accessible and the data can be analyzed much quicker. Now, let's talk about machine learning on AWS. First of all, what is machine learning? Using technology to discover trends and patterns, compute mathematical predictive models based on factual past data, build learning models, and make predictions. Starting off with artificial intelligence. It includes really any technique that enables computers to be able to mimic human intelligence. This could be a simple OR logic, an if-then statement. It can be programmed by hand too, as it mimics human intelligence. A subset of that is machine learning, which utilizes machines and lots of data to search for patterns in that data and build logic and models automatically. Essentially, with machine learning, we have a machine that learns based on patterns in the data or come up with its own paradigms and discover its own patterns in that data. Another subset of machine learning is deep learning. This uses a multi-layered approach to perform tasks like speech and image recognition. That often requires lots and lots of data and many more features. Let's dive a bit more into machine learning. Amazon itself is an example of a company that went through a multi-year machine learning journey in order to be ML driven, like the company you see today. Amazon had been applying ML in areas such as personalization and supply chain for more than 20 years. ML is an integral part of Amazon. We've improved that original personalization model significantly over time and moved it to other products such as Amazon Prime. We use ML throughout our fulfillment process, including the development of a forecast system that can predict the appropriate amount of demand for each product we sell worldwide. In order to deliver on our customer expectation on convenience, cost, and delivery speed, we've developed natural language processing technology to give consumers an entirely new way to interact with technology through Alexa. We've also developed groundbreaking technology with autonomous flight via Prime Air drones and using robotics in our fulfillment centers to get packages to consumers faster. This was a big cultural change for us, but it's something every organization can do. Within AWS, we see the machine learning and AI services, essentially the stack, as having 3 layers. The top layer that we see here, these AI services, they can be integrated and used pretty much immediately in applications where developers have little experience or time for developing models from scratch. The bottom layer of the stack is for expert machine learning practitioners who work with the framework or at the framework level and are comfortable building, training, tuning, and deploying machine learning models. The middle ML services layer provides features and tooling for developers and machine learning experts to use a more managed option. This increases the speed at which they train, tune, and deploy their machine learning models. Let's go ahead and take a closer look at the middle layer of the ML services with Amazon SageMaker. Traditional machine learning development is complex, expensive, time-consuming, and error-prone. Amazon SageMaker removes the difficult work from the process and empowers you to build, train, and deploy ML models quickly. Before SageMaker, doing ML was just too hard for most customers. By making ML easier at low cost, customers can make better use of their data, which is both valuable and differentiating. Amazon SageMaker makes it easy to deploy your trained model in production with a single click, so that you can start generating predictions for real-time or batch data. Let's have a look at a use case here. The National Football League, or NFL, has 180 million fans worldwide. They have engaged with Amazon Machine Learning Solutions Lab. They had a problem where basically they were generating 3+ terabytes of data and had over 1,500+ hours of playtime per week. They were gathering lots and lots of data, but they needed a solution for real-time stats, for reporters and sports announcers to be able to generate those stats during the game, while it's being played. The solution they picked up was something called Next-Gen Stats. Live data was streamed to AWS from RFID tags on the players themselves and the ball that was being used in the game. Then those machine learning models were built within Amazon SageMaker, so the predictions could be made in real time. That's a really good real-life application for being able to generate that data and report on those metrics for all the fans, the newscasters and sports announcers to get that information as the game was being played in real time. In this demonstration, we're going to have a look at 2 machine learning services. The first is Amazon Transcribe, and then later is Amazon Comprehend. We're going to start by using a real-time transcription to transcribe what I say into text. Let's click Start Streaming and speak into my mic. Hi there, my name is Jack. I really love pizza, but I hate pineapple on my pizza. I think I'll order some pizza for next Tuesday. And you'll see here that my speech has been transcribed into text. Let's copy that text and use it in our next demonstration. Amazon Comprehend is another natural language processing service where you can analyze an input and process it in different ways. Let's paste in our copied text from Amazon Transcribe. When we analyze this text, you'll see here that we can get an output of its contained entities. You can see there's a detected person, Jack, and there's a detected date of next Tuesday. We can find some key phrases, determine the language or languages of the text, which is English. We can look for personally identifiable information, or PII. I can see that my name Jack is detected. You can also find the overall sentiment of the text. You'll see here that it's mostly a mixed sentiment because we love pizza but we hate pineapple. And then we can dive a bit deeper into targeted sentiment, where you can determine the specific sentiment of entities within the text. You can see the positive sentiment of loving pizza and also the negative sentiment of hating pineapple. And then finally, there's also syntax. Now, as with all AWS services, we have an internet accessible API, which we can use to build our own custom applications powered by Transcribe and Comprehend. In this final part of the demonstration, we have a full application combining both services where I can input some recorded audio and then obtain the targeted sentiment analysis with my own custom interface. I'll start by uploading a recorded book review. Once uploaded, it will be sent to the Transcribe service, where you can see here the resulting transcription as text. Then this text gets sent to Amazon Comprehend to show the targeted sentiment analysis results, determining that I had a positive sentiment towards the book's storyline, but I had a negative sentiment towards its long length. And that concludes both our Amazon Transcribe and Amazon Comprehend demo. Next up, let's look at blockchain. Blockchain technology is well suited for complex workflows that span multiple organizations. Some of you might be familiar with different implementations of blockchain. Possibly one of the most significant or recent implementations of blockchain is Bitcoin or Ethereum. But blockchain can actually be used in a variety of other applications too. And if you're not familiar with blockchain as a concept, blockchain makes it possible to build applications where multiple parties may need to exchange transactions, and maybe there isn't a central authority in that situation. Here we're dealing with the notion of decentralized trust. But today, in order to use blockchain in a variety of different applications, it's actually pretty difficult to get started. Building a scalable blockchain network with existing technologies is complex and hard to manage. There are a couple of things that each of the network members in the blockchain or those who participate in the blockchain need to do. One is manually provisioning hardware. Another is installing the software, knowing what is the right version of the software that needs to be implemented and also keeping those things up to date. Creating and managing certificates for access, control to the blockchain, and then configuring network components. None of these things are insignificant. Especially for something as complex as a blockchain, it cannot be easily implemented. Let's take a further look at what is blockchain.
A blockchain is a distributed ledger that is decentralized, distributed, and immutable, enabling automated process workflows. Let's look at an example that demonstrates how this technology works by visiting the voting process. Traditionally, people go to a trusted location to cast their vote. They mark their ballots, which are submitted through a centralized, trusted party. It's a system that's been developed over a long period of time. But what if, instead of mailing a ballot or visiting a voting booth, you vote using a private digital voting token that's linked to your identification when you register to vote? With a distributed ledger, voter registration, verification, collection, and tallying can be automated. And it's trusted by everyone because identities are protected with digital signatures. The ledger is shared across multiple parties, and any changes made must be agreed upon by all. Participants can see the history of the immutable ledger, replacing the traditional previous need for a trusted third party. This is just one example of how blockchain technology can transform a common process. So how can building a blockchain on AWS be beneficial? You can build a superior blockchain solution by using AWS APIs and service integrations. Just like with a database, you can use the wide range of AWS capabilities to perform various functions on a blockchain. For example, technically savvy voters could incorporate AWS analytics services to gain insights to what is taking place on a blockchain. They could also create live streaming visualizations of how each group is voting across a geographic area. Give your blockchain superpowers, AWS.
Let's look at some example use cases for blockchain here. Shipping. Blockchain can be used to ensure the entire history and the integrity of that history of a shipped item as it's moving from one country to another and going through that entire shipping system all the way through to delivery. We can ensure the integrity of that item. From raw sourcing all the way through to delivery, we can independently audit and verify that the entire journey there to make sure that the item that was shipped, where it originated from, the item that we are receiving, with a certain degree of confidence. With blockchain, supply chain companies can document production updates to a single shared ledger, which provides complete data visibility and a single source of truth. Another really big use case here is finance and banking, assuring that the transactions are legitimate. Having a way to basically be able to agree amongst multiple different parties within a network that those transactions are valid and correct. Let's now see some of the qualities of blockchain that enable those use cases. First, this idea of decentralized trust. We talked about financial institutions, maybe mortgage lenders, basically being able to agree amongst multiple different lenders or parties that a certain transaction that happened truly happened. They're able to agree on a sequence of steps, or the origination of a loan and various components like that. All of the participants in the blockchain network here are able to agree on what happened. And importantly, they have transparency to be able to do that. Shifting over to the benefits here. In terms of the transparency around those transactions that happened, every member of that network is able to participate and have the visibility to what transactions have happened and the data behind those. Immutability. In terms of the transaction, it can't be altered in any way. Once it has happened, it is permanent in nature. And auditability is one of the other benefits that we get here. Being able to audit that certain controls were followed and certain regulations were followed. It's permissionless. The idea that we don't necessarily need to have a certain central authority to be able to give permission within the network here. Everyone is in agreement or not in agreement based on a consensus model. Now, in order to get this decentralized trust and the associated benefits, we need to be able to set up the blockchain. It's actually quite complex to set up a blockchain in terms of standing up the right infrastructure, using the right applications, and the right code to be able to do that. One solution to this is AWS Blockchain Services. Amazon Managed Blockchain is a fully managed service that makes it easy to create and manage a scalable blockchain network using popular open source frameworks like Hyperledger Fabric and Ethereum. This is something that makes it a lot easier for multiple parties or peers on a network to set up a blockchain. Amazon Managed Blockchain is fully managed. The idea behind fully managed in this case is that you don't necessarily need to wait weeks and weeks for the blockchain to be built out according to the specification. You can create a blockchain network in a matter of minutes. It has open source variety, as you have the support for two popular frameworks, Hyperledger Fabric and Ethereum. It's decentralized to democratically govern the network. Don't have any one member that is more important than another member, or that can override or change or mutate the state of certain transactions. There are lots of other components of this, but also a familiar pay-as-you-go pricing structure, only paying for the resources that are being used. And it's integrated, of course, with other AWS services that you can really take development on that blockchain much further. Let's look at one example of this being used. Nestlé is a global food and beverage company with more than 2,000 brands and distribution across 189 countries worldwide. They wanted to uncover transparency around its coffee bean supply beyond just the brokers and suppliers. They really wanted to have an understanding of traits of the raw materials and more visibility into that. They wanted to track every point in supply chain for this premium coffee. They chose Amazon Managed Blockchain to trace back every single step in the supply chain from the farmer to the grader to the roaster and then to the packer. You think about all the steps that are going along in a typical process of actually growing and sourcing all the way through to when those are being packed and eventually sold. This is an excellent use case where you want to understand the supply chain. In the case where the largest amount of coffee bean procured around the world, Nestle and their customers can now track the high quality, single origin coffee from a farmer, logistics, distribution center to the customer. Next up, we have AWS Ground Station. Satellites are used for a wide variety of use cases, including weather forecasting, surface imaging, communications, and video broadcasts. Sending satellites into space is becoming more and more common and accessible. We're getting more data back from the satellites than ever before. Some real-world examples include weather forecasting and agriculture. Being able to monitor crop health and the use of water across fields allows commercial fruit producers to use resources more efficiently. Another example is global shipping and anti-piracy. Understanding accurate ship positioning around the world using satellite imagery and telemetry. Earth observation and fire safety, helping fire commanders understand where the lowest heat entry point to fight fires is and the most efficient way to do so. Retail forecasting. As simple as it may sound, understanding how many cars are parked in a small mall can help vendors understand how often people are going shopping and how much money they are spending within those retail stores. Getting this data back has become much more accessible, but there are still some challenges that remain. Even as it's becoming more common and more accessible to send satellites out to space, the infrastructure required to be able to bring data back is still challenging for governments, universities, and businesses. Today, you must either build your own ground stations and antennas, or obtain long-term leases with ground station providers, often in multiple countries, to provide enough opportunities to contact the satellites as they orbit the globe. The actual ground station antennas in this case are often difficult to maintain, and it requires a high capital expenditure to actually scale up and collect the data. Even if you can get more satellites out to space and retrieve more data, there are still these challenges in terms of the actual infrastructure. This is where AWS Ground Station comes in. AWS Ground Station eliminates these problems by delivering a ground station as a service. This enables you to easily control satellite communication. It is fully managed service that lets you control satellite communications, process that data that's coming in. Scaling your operations without having to worry about building or managing your ground station infrastructure. Those actual antennas that you need to lease or to buy to retrieve that data makes it a lot easier with the ground station service. It's a fully managed service, so you don't have to worry about the infrastructure and scaling components underneath that. It requires no maintenance, software updates, or application downtime. AWS does all the heavy lifting for smooth and secure operations. Pay-as-you-go pricing, pretty incredible. Having the ability to just pay for the resources as you need them. And if you no longer need them in the future, you can release them and you don't have to pay for them any longer. There's no licensing requirements here. You can scale your satellite communications as your business needs. As a further reading, there's a great public sector blog post available called Earth Observation using AWS Ground Station, a how-to guide. I recommend checking this out if you're interested in finding out how to get started with Ground Station. Upon completion of the guide, you'll end up with a processed image of the Earth captured using AWS Ground Station. Here's an example taken of the United Arab Emirates and Oman. If you look really closely at the center left, you might see the Palm Jumeirah Island off the coast of Dubai. Now we'll talk about AWS Wavelength. Let's first discuss a couple of drivers for AWS Wavelength. With the advancement of onboard capabilities for many mobile devices, sensors like I mentioned before with IoT, video cameras, and many other devices that are generating large volumes of data. This data often needs processing very close to the point of data generation. There's a need to essentially have more infrastructure behind the scenes ready to be able to process that data locally and quickly. There's another driver here in terms of 5G and mobile edge computing. 5G proliferation for the next 4 years, it's projected that billions of mobile subscribers are going to be on 5G or 5G ready equipment. We have new use cases like cloud gaming, video streaming, IoT, connected vehicles, and other applications. And then finally, mobile edge computing. Certain applications, like games demand, require low latency and local processing on those mobile edge computing devices. These drivers are some of the reasons for a need for a product like AWS Wavelength. AWS Wavelength combines the high bandwidth and ultra latency of 5G networks with the AWS services that we talked about earlier to let developers innovate and build a new class of applications using those low latency and high bandwidth with 5G. Essentially, we have scalable capacity within the communication service providers, or CSP, with those data centers that are managed and supported by AWS. AWS compute and storage infrastructure is embedded inside the communication service provider mobile network. All the processing and storage can happen much closer to the end user, again taking advantage of that low latency for the specific applications. You then have access to services in AWS regions. You can develop applications and deploy them for use with 5G networks globally. A few example use cases for AWS Wavelength. Healthcare is one industry where Wavelength is really making an impact. AI or machine learning solutions for processing the images that are taken from multiple different types of equipment in hospitals for radiology and being able to do real-time diagnosis on a very large images or video that's taken from those machines. Connected vehicles, which we'll see an example of in a moment. Smart factories. Industrial automation applications use ML inference at the edge to detect quality issues on fast-moving assembly lines and trigger actions to remediate the problem. AWS Wavelength enables these applications to be realized without having to use expensive GPU-based servers on the factory floor. The amount of technology enabling vehicular communication systems to the degree in which technologies are interconnected continues to advance at a rapid pace. LG Electronics is using a next-generation CV2X platform on the Verizon 5G network using AWS Wavelength to move data in real time. It uses AWS Wavelength for low latency, high throughput for connected vehicles. You might have autonomous or connected vehicles that need to be able to send large volumes of data, potentially stream it in real time, and process that data very, very quickly with low latency and get either decisions or data points back to those vehicles. Over the 5G network, without having to go all the way back to the regions, are excellent use cases for something like AWS Wavelength. Now this concludes the module Innovation with AWS. We hope you found the session helpful with some of the newer innovation areas like IoT, machine learning, blockchain, wavelength, and ground station. Thank you again for attending, and we really appreciate your feedback so that we can better understand the topics and services that you would like to know more about. So please do take the time to fill out our survey and let us know what you think. And with that, I'd just like to say thank you so much for joining us at Awesome Day Online Conference. Join us for Module 5, where we'll talk about the next steps in your cloud journey.